London is one of the most vulnerable cities on the planet when it comes to flooding. So I've come to Molesey, a few miles out from the centre of town, to find out how the engineering that's happening here will protect city dwellers.
This part of the River Thames in Molesey contains a giant engineering structure called a weir. Chartered civil engineer Ayo Sokale explains to me exactly what it's doing here.
I'm working on the River Thames scheme and we're trying to reduce the risk of flooding from Egham in Surrey to Teddington in southwest London. So what happens usually when we have a heavy rainfall event is that the River Thames gets overfull and it bursts its banks. So what we're going to do is build more than 5 miles of flood channel that's going to come off the River Thames so that when it's got heavy rainfall, it goes there instead.
Take me right back to basics, like what exactly is a weir?
Well, a weir is like a kind of small dam of such really, and we're going to be looking at a fixed crest weir. So that means that when the gate is up, you've got a fixed structure and the flow goes over it.
Just seeing it with our own eyes is going to make us understand exactly how this thing works. We're in the middle of the Thames River and you've got these gates. What exactly are they doing in their most fundamental purpose?
It's very hard to say they do one thing. They're kind of a multifunctional purpose asset.
So these are actually controlling the flow.
Key thing here is they help us maintain the head flow. So you can see now when we were looking at it, we've got a level that's been set at and that determines how much flow is coming over. You can't see all of it. They're 3.4 meters wide, but they're 3 meters deep. So you can only really see some of it above, but this structure goes right into the ground, concrete foundations, apron structures, all keeping the whole thing secure. So, I mean, you're seeing some of the asset, but lots of it's also below water, below the surface.
Why does it need to go so deep?
Foundations are so important, and especially when you're talking about like assets are near water, you have to design for their hydrostatic load. So think about it, if you have a greater depth of water, you're having more pressure, more force, and that's what we're designing to make sure this is robust, because assets like this, like the concrete structures, they're designed to last for like 100-year design life. But the mechanical parts, like the moving parts, because they also tend to have more point failure systems, are designed to last for 60 years. So, you know, 60 years. So we really design these things to be robust to the loading, but also for the future.
So who gets to decide on the gate?
The lockkeeper controls all of this stuff.
Oh.
He is the guy.
There's the engineers like you who are doing all the calculations, the design, the build, and then there are guys like the lockkeepers who have been doing this such a long time. They're probably seeing the changes in technology.
One of the things about weirs is that we need them, but they're actually an obstruction on the river. And fishes and eels, they need to migrate across the river. First of all, to find somewhere to spawn, to find food, and for safety.
It's getting very dramatic here. The gates have been opened.
This is what engineering is about.
A lot of engineering means building this massive infrastructure, but a huge part of that's also making sure it's done in a sustainable way. After all, we're doing work like this to reduce the risk of flooding, which is exacerbated by climate change, so we should also be doing our bit to look after the environment. Water companies need to take water out of the river, and these go into reservoirs, and around this area there are so many reservoirs. There's a whole network of reservoirs for abstraction and storing water, which is then taken to London as drinking water. When you turn your tap, you get water, but actually we maintain the level here that someone can take the water that you then drink at home.
My understanding of this, there are gates which control the flow of the water into the river, and there's a 3-pronged approach. There's controlling the flow of the river so that boats can come and go, and then there is maintaining depth of water, and then there's looking after the fish. Because at the end of the day, this is a river and it's the habitat for fish. So explain to me what's happening, because it's very calm on that side and it's kind of crazy on this side.
Yes. So here you can see that the gate's allowing some flow of water, so it's not completely down, so we're seeing the flow of water coming through. You're getting like that kind of turbulent behaviour, and that's what's also coming up at the surface, because we've got this up at the moment, but not entirely up, because if it was entirely up you'd have way more flow of water going over this.
I'm loving all this kind of mechanical devices.
So these are all automated. Historically on butt gates, these would have been hand cranked.
Are there sensors along this bit?
Yeah, so there's sensors along here and more primarily at our gauging stations all along the river. And our gauging stations lead into our kind of app system that tells us what the flow is.
And all these different pieces of engineering are basically working in unison.
Yeah, because we had to think about when there's too much water, when there's too little water, and it's just a lot of different things that have to be factored in. So engineers designing this have designed it for multi-purpose, so it really achieves, but also they've also tried to design it for a changing climate.
You know, when I was doing my PhD, I was literally around the corner, coming here every single day for 4.5 years. Never really noticed the water, and after today, I've just been introduced to this whole complex structure that looks simple, but is doing so much. I hope that this has given you an insight. It really has done for me, and we keep on protecting our environment and our lives with amazing engineering.